This is problem number 77 of the 2012 AP Calculus exam. Let f be a function that is continuous on the closed interval from 2 to 4, with f of 2 as being equal to 10 and f of 4 as being equal to 20. Which of the following is guaranteed by the intermediate value theorem? Well, let's begin by looking at a graph. We can plot the value of 2, 10. When the x value is 2, the y value will be 10. And we can plot that point. And we can plot the point where the x value is 4 and the y value is 20. And look at the graph, and it says, let f be a function that is continuous on that closed interval. So we want to look at some function that is continuous, and we can have any type of function here. We can draw a number of different ones. We could have something like this. We could have, let's put it in a different color maybe, something like this. We could have a function that's just a straight line. All sorts of things that we could have there as far as possibilities. The main thing is, it has to be continuous. We can't have any breaks in the graph. We could even have one that's coming down and up like this. All sorts of graphs. Now let's look at the statements and determine which one would be guaranteed by the intermediate value theorem. Well, the first one is f of x equals 13. So let's look when f of x is 13. Let's just draw a line straight across. Then we have at least one solution on that open interval from 2 to 4. In other words, it's going to intersect with our graph at least once on that open interval from 2 to 4. And if we consider all of those functions that we graphed, all of them would have had an intersection on that graph. And that's what the intermediate value theorem states, is that if we have a continuous function, then there will be, in between that open interval from 2 to 4, some y value that's going to be between 10 and 20. And that will be a coordinate on the graph where you have the x values between 2 and 4 and the y value is between 10 and 20, and that's guaranteed by the intermediate value theorem. So answer A is going to be our answer, solution A. But let's go ahead and talk about B, C, D, and E. F of 3 is 15. So if we look at 3 and 15, it says f of 3 would have to be 15. And we see, well, not really. It doesn't have to. It could have been f of 3 was way up here at the top, or f of 3 could have been way down here at the bottom. It doesn't have to be at 15. So it's not letter B. Letter C. F attains a maximum on the open interval from 2 to 4. Okay, so we're looking at, is there a maximum value on that open interval from 2 to 4? Will that happen? Well, and the answer is no. We have the endpoint. Let's look at this one that's in black. The endpoint is going to end up being at 420. That is our maximum on the maximum of the function f, and that maximum is not in between that open interval from 2 to 4. So f attains a maximum at, in this particular case, at the value when x is 4, not on that open interval from 2 to 4. So it's not letter C. It would be at our endpoint. Now, would it have to be, would the endpoint have to be the max? Well, we look at the one in green and we notice that one had a maximum that was on that interval that was greater than 4. So the 4 doesn't have to be, but on letter C it was saying the maximum had to be on that open interval, and it would have been on the case if we had the function that was in green, but it would not be in the case if we had a function like that was in red, or that was in black, or that was in blue. And so it's not guaranteed by the intermediate value theorem that it's going to have a maximum on that open interval. So it's not letter C. Letter D, f prime of x is equal to 5, has at least one solution in the open interval from 2 to 4. Now, if we look at the slope between those 2 points, and we had the slope as being y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and so we could have that slope as being 20 minus 10 over 4 minus 2. And we see that that is 10 divided by 2, and that slope is 5. And so what we're seeing here is the slope of the secant line is in fact 5, and there will be some point on all of these graphs, at least one, to where we have a parallel slope. But that's not what the intermediate value theorem guarantees. That's the mean value theorem. And so, wrong theorem here. So f prime of x does equal 5, and there is one solution on that open interval from 2 to 4, but that's not what the intermediate value theorem guarantees. That's what the mean value theorem guarantees, so it's not D. Answer E. F prime of x, the first derivative of x, is greater than 0 for all x. Well, we see in the one in green that we have some that's positive, tangent line's positive, but also negative. The one in blue also has positive and negative slopes, and the one in black has positive and negative slopes. The only one that we had that was positive everywhere was that function that we used that was a straight line that went through those 2 points. So it's not guaranteed for all, and it's not going to happen for every function, and that's not what the intermediate value theorem guarantees. And so it's not letter E. Our answer choice is A.